So January 2022, question number 9, this says, the diagram below shows a circle with um, the points P, Q, R, and S lying on the circumference, and its center marked O. RP is a diameter of the circle. AB is a tangent to the circle at P. The angle APQ is 3x. The angle QPR is 2x. Angle RPS is x. And angle QSP is 54 degrees. Next, we're asked to determine the value of each of the following angles, show detail working where possible, and give a reason for your answer. The first thing we're asked to do is to determine x. All right. Now, to determine x, this is what I'm going to use. I'm going to use the fact that this angle here is 90 degrees. That's what I'm going to use. I'm going to use the fact that angle OPA is 90 degrees. So I would say to the examiner, angle OPA is equal to 90 degrees. And the reason for that is that the radius OP at point of contact P is at right angles to the tangent, and the tangent is AB. Is at right angles to the tangent AB. So that is the reason, that's the circle theorem reason why that angle is 90 degrees. So because that angle is 90 degrees, I can say that 2x plus 3x is equal to 90 degrees. 5x is equal to 90 degrees. Divide both sides by 5, and I'm going to end up with x is equal to 18 degrees. So we're asked to find x, and we did that. Next, we're asked what? Find y. Let's go back to our diagram. All right, y. All right, what are we going to use to find y now? All right. All right, to find y, what is coming to my mind is to use the fact that this angle is 90 degrees. Angle RSP is equal to 90 degrees. It's an angle in a semicircle. So I would tell then these three angles, y plus 90 plus x, would be equal to 180 degrees. So I'm going to use that. RSP is 90 degrees. So I'm going to tell the examiner that angle RSP is equal to 90 degrees. Angle RSP is an angle in a semicircle. And if you want, you could write an angle in a semicircle is equal to 90 degrees. You didn't have to. So if that angle is 90 degrees, then now y plus 90 plus x is equal to 180 degrees. So y plus 90 plus x is equal to 180 degrees. They are the interior angles of a triangle. So y is 18, I can say that, sorry, x is 18, that y is equal to 180 minus 90 plus 18, because x is 18, it's equal to 180 minus 108. Y is equal to 72 degrees. Let's go back to the diagram, guys. Now, the next thing we need to find is Z. Looking at the diagram, I can see that whatever Y is, Z is the same thing, and there are angles in the same segment. This is how we identify angles in the same segment. You start at X, one end of the chord, up to the circumference, down to what? P, which is the other end of the chord, sorry. You start at S, again, up to Q, the circumference, and then down to the other end of the chord. Now, when you have a situation like that, when you have two angles starting and ending on opposite ends of the chord, and the vertex of the angles are formed at the circumference in the same segment, those two angles are equal. They are called angles in the same segment. So I'm going to say that Z is equal to whatever Y is, which is equal to what? 72 degrees. So angle Z and angle Y are angles in the same segment. Moving on. All right. Next, now we're at bearing. Very popular. In the last couple of exams, we see circle theorem and bearing a lot. If you're prepared for it, pray for it. If you find yourself prepared for it, pray for it. This says, sorry, the diagram below shows straight roads connecting the towns L, M, N, and R. L, R is 18 kilometers. LN is 12 kilometers. MN is 10 kilometers. Angles RLN is equal to 25 degrees. Angle LMN is equal to 88 degrees. We're to calculate the angle MLN. Angle MLN. I need this angle here. So angle MLN, looking at that triangle, I noticed that I have two sides and a non-inclusive angle. Now, if I have two sides and a non-inclusive angle, and I wish to find the size of the second non-inclusive angle, I'm going to have to use the sine rule. So I'm going to call this angle theta. And I'm going to say sine theta over the side opposite to the angle is 10. So sine theta over 10 is equal to sine 88 degrees over the side opposite to 88, which is 12. I'm going to bring my 10 up here and say that sine theta is equal to 10 sine 88 divide by 12. Then I'm going to put this in my calculator and press equal. What I want is I want 3 decimal places. 10 sine 88 divide by 12, and I want 3 decimal places. Please ensure your calculator is on the correct setting. This says 0.833. That's what I'm seeing. 0.833. So this is 0.833. So theta would be equal to sine inverse 0.833. So if I know the sine of an angle, to find the angle, I must use sine inverse. So it's shift sine open brackets, 0.833, close bracket, equal, and this is 56 degrees to 1 decimal place. So angle MLN is equal to 56 degrees. All right, so we have 56 degrees there. Next, we're asked to calculate the distance NR. NR is part of this triangle at the bottom. For this triangle, I have two sides, 12 and 18, and the angle between them is 25. If I have two sides of a non-right angle triangle and the inclusive angle, and I wish to find the length of the third side, that is a condition for applying the cosine rule. Now, the cosine rule says a square is equal to b square plus c square minus 2bc cosine a. In the cosine rule formula, A is the side opposite the inclusive angle. The inclusive angle is 25, and the side opposite the inclusive angle is NR. All right, so in the cosine rule formula, A is the side opposite the inclusive angle. The inclusive angle is 25, and the side opposite the inclusive angle is X. So this is X squared. Now A and B are the other two sides. So this is 12 squared plus 18 squared minus 2 times 12 times 18 times the cosine of the angle between them, which is 25 degrees. I normally tell students to just put everything in the right in the calculator and press equal. So this is 12 squared plus 18 squared minus 2 times 12 times 18, the cosine of 25 degrees, press equal, and this says 76.48. This is 76.48. The opposite of square is square root. So X, which is NR is equal to the square root of 76.48. So NR is equal to the square root of 76.48. NR is 8.7. Let's work with 8.7. Yeah, let's go with 8.7. 8.7, we could say 8.75. All right, let's say 8.75 for now. 8.75 kilometers. NR is 8.75 kilometers. Lastly, we're asked to determine the bearing of tone R from tone L. We need the bearing of tone R from tone L. Now, I'm taking the bearing from tone L. So at tone L, I have a north-south, east-west line. Bearing is measured clockwise from north. So I'm going to start from north and come around with my arc to the line that connects R and L. So that entire angle represents the bearing of R from L. And that angle is 50 plus 56 plus 25. So the bearing of R from L is 50 plus 56 plus 25. All right, and the final answer there, I think, is 131 degrees. The bearing of R from L is 131 degrees.